Hi there, hope you have a fantastic day today. This lesson we're going to prove diagonals of parallelograms. Please get your pen and paper ready, we're going to work together. So let's get into it. This video we're going to go through two syllabus dot points. So this dot point here and this dot point here. So just let's get into this. First one. Prove the diagonals of a parallelogram meet at right angles if and only if it is a rhombus. So let me just construct a rhombus first. So let's name these vertices I, B, C, D. So let ID is vector I and IB is vector B. Since quadrilateral IBCD is a rhombus, so this means that AB is equal to DC. So that is vector B. And BC is equal to ID. So this is also equal vector I. And the magnitude are the same, of course. So the idea is we need to prove IC, vector IC is perpendicular to BD. So perpendicular to vector BD. So in vectors, when the two vectors are perpendicular, this means that the dot product is equal to 0. So this means that IC dot BD is equal to 0. Okay, that's what we're aiming for. So let's just find vector IC and find vector BD. Okay, and then we just find the dot product. So IC is equal to, so we have IC is this vector here. So that is equal to IB plus BC. So that is IB plus BC. But IC is vector B and BC is I. So this is exactly the same as vector I plus vector B. So let me just write this down. Therefore, IC. So now we need to find the vector BD. Okay, this vector here. So this vector here is equal to vector I minus B because opposite directions. Okay. So in another word, let me just write this down. So vector BD is equal to BC at CD. And we know that BC is vector I plus CD, this vector here is negative B. So that is equal minus B. I just write like that, okay? So there you go. So now we just need to find the dot product of vector DC and BD. So let me just write it here. So IC dot BD is equal to, so IC is this vector here. So that is I plus B dot vector BD. So BD is this vector here. So that is I minus B. So to work out this product, this is exactly the same as just normal expanding, okay? So this here is I dot I. And this here is I dot negative B. So this is minus I dot B. And this one here is B dot I. Is exactly the same as I dot B. So just write I dot B. And these two together is minus vector B dot vector B. And don't forget, I dot vector I is equal to the magnitude of I square. Okay, so keep that in mind. So therefore, this means that these two here, which is I magnitude square. And we have negative I dot B plus I dot B, so that cancel out. And this one here is magnitude of B square. So that is minus magnitude of B square. But then because this quadrilateral is a rhombus, so this means that all sides are equal. So we know that I magnitude of I is equal to magnitude of B. So this means that magnitude of I square is equal to magnitude of B square. So that is equal to 0. So therefore, IC dot BD is equal to 0. So therefore, IC is perpendicular to BD. So there you go. Second dot point. Prove the sum of the squares of the lengths of the diagonal of a parallelogram is equal to the sum of the squares of the lengths of the sides. So let me just construct a parallelogram first. So let's label vertex A, B, C, D. Let's say ID is vector I and vector AB is vector B. And since it is a parallelogram, so this means that opposite sides are equal and parallel. So that is vector B, and ID is equal to BC. So that is vector I. Now we need to prove that AB square plus the magnitude of BC square plus ID square, and we add DC square is equal to BD square plus IC square. So IC square plus BD square. So that's what we need to prove. So let's just work out the magnitude of AB square plus BC square plus ID square and plus the magnitude of DC square first, okay? So let me just write this down again. So AB square is this magnitude here, so which is B square. So magnitude of B square, and we add BC, so BC is magnitude of I square. And we add ID square, so ID square is this one here, so magnitude of I square, and we add DC square, so DC square is magnitude of B square. So I can just simplify this further. So that's I magnitude of I square plus magnitude of I square is 2 magnitude of I square plus magnitude of B square plus magnitude of B square. So that gives me 2 lots of magnitude of B square. Now we need to find the magnitude of IC square plus BD square. So let's just find IC first. So vector IC. So IC is this vector here. So that will give me vector B plus vector I. So give me IC. So vector B plus vector I. So that will give me vector I plus vector B. To find the magnitude of IC square, so magnitude of IC square is equal to IC dot IC. But then we know that IC is I plus B. So that means I plus B dot I plus B. So now we just work this out. So this is I dot I, and this is plus I dot B. And b dot I is exactly the same as I dot B. So I just write I dot B. And this is b dot B. And we know that I dot I is magnitude of I square. B dot B is magnitude of B square. So let me just write this down. So this is magnitude of I square plus, so this one here, which is add them up, 2 lots of that. So 2 lots of I dot B. And plus B dot B is magnitude of B square. Now let's work out the vector BD first. So vector of BD, so BD, that will give me, so BD is this vector here. So that is equal to I plus negative B. So that means I minus B. So vector I minus vector B. And we know that the magnitude of BD square is equal to BD dot BD. But then BD is vector I minus vector B dot I minus B. So now we just have I dot I, and this is I dot B, but it's minus. And this is minus B dot I. But B dot I is exactly same as I dot B. So just write I dot B. And this one here is plus B dot B. So there you go. And we know that I dot I is magnitude of I square. B dot B is magnitude of B square. So let me just write this down. So this is magnitude of I square. And we collect like terms. These two add together, give me 2 lots of that, but minus, okay, I dot B. And plus B dot B is magnitude of B square. So now we just add these two together. So now magnitude of IC square plus magnitude of BD square. So magnitude of IC square is this bit here. So let me just write this down. Then we plus this BD square is this bit. So just add magnitude of I square minus 2I dot B plus magnitude of B square. So now we just collect like terms. So these two here can cancel out. And we have magnitude of I square plus magnitude of I square. So we have 2 lots of that. Magnitude of I square. And we have magnitude of B square. We add another. And we add another one. So that's 2 lots of that. So plus 2 lots of magnitude of B square. So this is equal to magnitude of AB square plus magnitude of BC square plus ID square at DC square. So therefore, so there you go. Thank you so much for watching. Bye.